I need to mute the tab. So I guess you're not on any of those. Okay, so we're live. And with that, I quickly also address the audience on LinkedIn and Tobilo and Facebook. If you have any questions, post it into the chat or the Q&A tab on Tobilo. We may or may not be able to handle that because I know our AMAs are going much longer, and this is an interview, not an AMA. I just want to do that distinction. And just, yeah, hello to everyone in the stream. And with that, let's get started with the interview. So, hello, Titus. It's nice to see you. And in 3 weeks, I'll see you in Berlin. So I'm really looking forward to talking to you about all kinds of things with C++, your keynote, etc. today. But let's just get started with like what have you been up to recently?
Yeah, let's see. So I guess the big news for me is end of last year I left Google and now I'm working at Adobe. I'm now a senior principal scientist here focused on developer experience broadly, which I say developer experience is a polite fiction. We're really in the business of productivity. We just are smart enough to realize that you can't directly measure productivity, but experience is a very good proxy for that. So we're not in the business of giving every developer a donut. We're in the business of training and tools and infrastructure and giving developers, the tools that they need to create wonderful products. So yeah, I've been doing this since January, starting to actually ramp up a team here, and the ways that is related to, but very distinct from all of the things that I was doing at Google are really interesting so far. It's been a lot less direct C++ focus, although I certainly can't get away from all of that. Let's see, I've been working with Sean Parent and Dave Sankel and Dave Abrams on some of the like overall guidance and planning on how we're going to approach memory safety and other government security regulation stuff, which I think it's safe to say hits the C++ product lines rather more acutely than some of the more modern and more B2B type of products that Adobe has in its portfolio. And then, yeah, a lot of other stuff is just kind of groundwork, some of which a little bit related to the keynote that I'll be doing in a couple of weeks. Just focus on productivity. All of the research says the primary drivers and indicators on productivity actually go to kind of soft skills stuff. It's teamwork and collaboration and documentation and just the mechanisms by which we build a culture of learning on our teams. That seems to be by far the highest predictor of technical and business success. So a lot of stuff has been, all right, let's just take stock, breathe, focus on like how do we be nice to each other. So that's been really satisfying too. And a lot of those themes are going to show up in the talk in a couple of weeks.
That sounds interesting. Maybe let's just get started. What we, as an audience, what are we going to kind of, hear? Like, what is your plan for the keynote?
Yeah. So when you reached out to me months ago for the gracious offer to give me a stage there, I said specifically, like, I don't feel like I've been thinking about specifically C++ things enough lately to give a C++ talk. And I think it's really much more interesting to focus on teamwork and social dynamics and the stuff that we don't talk about as much. And especially because having just gone through a job shift and a job hunt, and with the rise of generative AI and everyone kind of panicking about those things, in the C++ community, the question of like, is memory safety going to kill us? Like, hey, is Rust coming for us? I think that there's a lot of fear involved in sort of our technical profession. And so I'm taking a big swing. I'm not 100% sure this is going to work out yet. It'll probably work out, but so I'm taking a swing on what. Let's step back and look at all of the places where I see our actions and behaviors being primarily fear-driven. A lot of hype cycle chasing, a lot of sort of performative labor instead of actually focusing on the things that are impactful. So there's a lot of those sorts of themes. I certainly try to get into what do we do to try to mitigate those pieces, as well as trying to surface the evidence that we have about like what is the impact of this, how acute is this, what works, what doesn't, and then I think that there's also going to be a few places in there where it's looking back. Several of the major forms of, if not fear, at least anxiety, are places where we actually started to just build technology to address that. And I'm not saying that you can always do that, but I think a lot of our industry approach towards we need a source of truth for this. We need a ground truth for what's committed, like what source code is current. Like version control is partly productivity for sure, but partly I think it's just an anxiety reduction of, I know what the ground truth is. I think you can make the same argument for CI in some respects. Like, I know what the ground truth is because there's someone I can ask. And especially when we make those systems automated, so you don't have any like social pressure or weird social dynamics in the mix of like having to ask that question. Like I can even see that like some of those developments are, whether intentionally or otherwise, kind of a fear mitigator. And if we think about it in those terms, are there other places where we could apply that same pattern? And I don't think that that's a panacea by any means. I think a lot of this really does boil down to active team culture building and being nice to each other, being professional. But I think there's a lot to be pulled out from all of that. So I'm really excited by the talk. It is just also just kind of a daunting topic to be diving into.
I think it's really keynote worthy. You know, it's like I didn't ask you to give a C++ talk, so
right.
And so for me, like one of the relations why I came to pick you is just that I find it interesting that you have had the opportunity to look into large organizations using C++ predominantly, and that also you have like your good share of time with C++ and the committee. And so I think that is a really good view on things. And then not everyone has to like, you know, just do a keynote on C++ directly. We have that, and we have plenty of those. What's kind of the differences you see between what you're doing now at Adobe and at Google?
Yeah, I mean, there's a lot. Like Google, I don't by and large feel like there's a substantial quality difference between Google engineers and Adobe engineers. Like these are very smart people in both places. I do think that Google's engineering infrastructure was, you know, deservedly has a reputation for being kind of amazing. And a lot of that was by necessity, just because of the scale of the operation, the scale of the monorepo, the scrutiny, and the, you know, security requirements. Like, you know, Google was attacks on Google are part of why, you know, the security community has terminology like advanced persistent threat. And so just having to operate at that heightened level of scale and security requirements and production, you know, efficiency and all of that stuff forces a certain level of rigor, I think, and discipline. Whereas Adobe has been a lot more growth through acquisition, and dip its toe into various, different business models and things. And a lot of the things that people recognize as Adobe are only a small portion of the overall portfolio. There's actually a lot of like analytics and B2B sort of things going on. It's a whole separate business unit. So it's very complicated and it's very fragmented. That growth through acquisitions has left a lot of things like not particularly integrated. And so coming out of a very consistent mono repo world with tens of thousands of users or tens of thousands of engineers playing in the same repository and sharing CI systems and sharing workflows, moving from that into a pretty much everyone does the things that they feel like doing. Like there's very little consistency on tools or workflow or anything like that. That has been eye-opening. There's a lot of like, oh, okay, I see why some of the things that we said as Googlers came across as, what are you talking about? How could that even be possible? Because without the assumption of a certain level of consistency, yeah, it'd be really hard. But that said, I think everyone at Adobe has been really excited by the suggestion of like how we can change and advance, and I find it really, really empowering in a lot of ways. And it's a smaller environment. It's a less, I feel like it's a less contentious, less political sort of environment as well. Like everyone seems like they want to be helping, whereas there was some times where I felt like we had leadership, especially that was just in turf wars at Google. So it's been really good, and trying to bring a lot of the lessons that we had to learn from scale back to Adobe for like, okay, I see how you got here, but if you're going to take that next step, we're going to have to shift that around, and that's going to be a little complicated. But there's been a lot of that, and early signs point in good directions. Like I also said, the government security regulations are really going to change how a lot of things in software operate, not just memory safety, but software bill of materials and secure supply chain requirements and all of these things. Like a lot of, well, we happened to make something kind of work and we shipped you a binary from 5 or 10 years ago is not going to cut it going forward. And so a lot of deferred maintenance things are going to come, those bills are going to come due. And
so you basically got to keep a paper trail for many things now.
Yes, got to keep a paper trail for many things, got to be much more upfront and open and honest about what components are going into your software and how certain you are that you understand all of those components. So 5 years from now, we will have a regulatory environment that is much more demanding of your build is entirely reproducible, and we understand all of the components, like third-party, that are involved in that build in any way, and we know the versions of all of those, and we know that there are no published vulnerabilities for those versions of those dependencies, et cetera, et cetera, et cetera. And that's going to shift the development workflow and tools and whole approach to software. So it's a crisis that I am going to use as an opportunity for sure.
Yeah, it seems like that. Is your new role like often also related to DevOps in this section, like that you're trying to improve and standardize the ways that flow into those processes?
A little bit. The org that I got put into already has a pretty solid like SRE production tone to it. So they have CD systems in particular, and they manage a lot of the like AWS and Kubernetes sorts of production resources and API systems. So like that's already kind of in place. And a lot of what I'm doing is kind of building that out to conceptually include desktop software and mobile software instead of just production backends and web stuff, as well as a greater focus on the CI parts instead of mostly CD. And then I get to beat the drum for a lot of people on, hey, CI means tests. You do have to be writing tests. You know, unit tests do matter, folks. So there's tech and education and best practice stuff and, you know, culture shift for sure. So
Yeah. Maybe in that context, you mentioned, and we all know that this is a thing coming from the government, like how do you handle safety in C++ at Adobe, and what is your involvement with that?
Yeah, so I'm on the sort of roadmap think tank group that is setting standards for memory safety. What we're currently, we lean a lot on a really good, I forget if it's a blog post or a paper from former colleagues at Google, I think it was that Chromium piece, about the rule of two, which is if you look at stuff that is handling untrusted inputs, which is really untrusted, complicated inputs, not like, yeah, you got an integer, but like, hey, here's a blob of data. Stuff that's handling untrusted inputs, stuff that is written in memory unsafe languages, which is C++, and stuff that is neither sandboxed nor fuzzed, preferably sandboxed. Like, you definitely can have only one of those as a, or you need at least two of those properties. If you have, I'm saying that backwards, but you know what I mean, right? And so just following from that reasoning, we're looking at sandboxing technologies. I believe Acrobat on most platforms currently is running in a sandbox in order to try to avoid some of those issues and mitigate. In cases where we don't have that option or we haven't figured out how to handle that architecturally, there is a meaningful amount of like fuzzing infrastructure, and I think improvements that can be made to all of that to continue to help there. Fuzzing doesn't solve all of the problems because we have to take fuzz results, you know, with some discipline and actually go react to it and go fix the problems. Knowing about them doesn't do it all. And that's a little hard in an environment that sometimes it's like, well, that problem has been there forever and it doesn't seem to be hurting users. So does it really matter? And I think we have to lean on the government regulation threat to be like, yes, now it matters. And I think that will also improve development velocity and things because we have fewer bugs that you can't understand or track down. And then of course there is a question of like, well, can we rewrite components where fuzzing or sandboxing are either too expensive or architecturally impossible? Can we write those in something memory safe? Rust is the obvious choice. But without good interop, that is a complicated question. I mean, that certainly gets back into Carbon or anything else that we can get reasonable FFI between C++ and some other language. And these are all big, outstanding questions that I think the industry is going to be grappling with for a while. But our approach is a lot of, if you have the capital investment available for like good quality engineers that can spend some time on architectural stuff, consider a rewrite or consider sandboxing. And if you can't afford human time on it right now, throw more machines at it, fuzz it, but you have to take that with substantial discipline. And that's, for the time being, kind of the best that we got. evolving.
Yeah, I mean, it's always good to have a roadmap and to plan ahead.
Yep.
So I know that Adobe has like their own language with Hilo, where Sean Parent and other folks have been working on. Do you see that in that space? Is that memory safe?
I have not followed Hilo all that closely, but Sean is also sitting on the memory safety roadmap group, and we are not pushing Hilo as the solution to all of these things. I think Hilo, has plenty of interesting points to it, and I certainly would not discount language design ideas coming out of Dave Abrams. But I don't know that it's a major investment or certainly not a solution for the problem in the next couple of years. So.
And I know that's like right now a big discussion everywhere, and I know it's like, let's go a little bit back to C++.
Sure.
I know you've had your fair time with C++ in management and in the committee. So I just, what is your reflection on, and your is your work with the committee?
Yeah.
I know with your new role, you're not as much involved again, but
right.
you've been pretty involved with the committee at Google.
Yeah. Yep. I'm reasonably proud of the time that I spent there, and there are certainly a lot of people in that space that I miss. There's a certain camaraderie that comes with spending, 3.5 weeks a year in very intense settings with the same group of people over and over again. And so, there's a bunch of people that I wish that I saw more of. Like, that's been kind of a loss. But I think if you look back at the papers that I specifically put forward myself, which was not my major focus. My major focus was like try to steer things in a sustainable direction. But all of the papers that I did write and propose turned out to mostly be plenary discussion types of things. And it was mostly about the question of how does C++ evolve? And the initial direction was how much effort are we willing to ask from users when they are doing a language upgrade? Because we pretend that that's free, but everyone knows it's not. And if the intentional cost, my argument was, if we set an intentional upgrade cost budget that is commensurate with the accidental cost of doing an upgrade, that seems like a reasonable thing and would allow us at least some level of, we can fix mistakes that we have only come to understand in retrospect. And we got sort of conceptual agreement to that perspective, because I think that's a very compelling argument, and people seem to be behind that. In practice, that didn't really go anywhere, because everything that was small enough to be a good trial run on that didn't feel like it was worth upsetting users. And anything that was large enough to be worth doing was too scary for us to take as a trial run. And so we were just kind of stuck. And then I realized at some point, I want to say it was probably Kona 2017-ish, 2018, that maybe the more dominant question was the ABI thing that has since become a much more popular topic in conference circles and things. And so the question that I brought to the direction group in particular was, is C++ 23 going to be an ABI break? And if not, are we ever doing this? Because if we aren't even going to ask users to recompile their code, we're clearly not going to ask them to make source edits to it either. And that kind of just became the root cause discussion of, is this a language about forward progress or backward compatibility? And the last meeting before COVID really broke out, the last in-person meeting that we probably shouldn't have been having in person. Let's maybe put it that way. In Prague, we did have a big plenary meeting about exactly this. And famously, it was definitely no consensus for 23. It was maybe kind of, if you squint, consensus for 26, but all of the people that were strongly against breaking ABI at that point happened to hold national body vetoes or be the implementers, which is enough for me to say, like, okay, we're never actually changing ABI. We should stop pretending that we're going to and focus instead on getting everything right, promising backward compatibility in a way that we don't currently, and like slow down. The nature of the game is different with that result. And the paper that I wrote at that point was like ABI now or never. And I was not joking. I was not being hyperbolic. Like in 23, it would have been a 12-year ABI, idealized ABI stability for Clang and GCC. And MSVC has been ABI stable since like 2015, I think.
Yeah.
Right. And the space that I live in, you live and die by Hiram's law. Like, doesn't matter if you promised that it's stable. If it's been stable, people are depending on that. And now I work at Adobe. Like, as far as I know, we've been pretty good here about for plugin APIs. We're not exporting complicated types across those boundaries, but that's because there's people like Sean Parent, like keeping an eye on that particular risk. I fully expect, like, if you look across the industry at, precompiled libraries, plugin APIs, any number of things, like there's ABI dependencies hidden in all of that in ways that the community doesn't understand fully. Because why would they? Like, it's an esoteric question for implementers that happens to be a thing that you can rely on without realizing. And so, like, by this point, like we're not taking an ABI break in 26. Are we taking an ABI break in 29, which would be
so actually
14 years of stability for Windows? And
a few weeks ago, I did an ARMA with Herb Sutter, and that question about ABI came up, and Herb said, well, this is only partly in the hands of the committee because ABI is a boundary for us.
Right.
And so since 2015, we're ABI locked, but it's not our decision to raise that lock because it's all of Windows. And this ship is a lot harder to move in a different direction and to steer. And the one point which I'm kind of sad about, and you probably should know this paper. There was like one paper, and I saw it once in a keynote by Bryce at C++ Now in 2021 or something. We had a paper which basically enabled through language interfaces to have ABI stability as a backwards compatibility, but then say this block is an interface which has an ABI ongoing from either a language standard or by user-defined ABI breakpoint saying like this is version 2 and this is the ABI of version 2. And I like that. I thought that this is kind of trying to solve this in a way that would enable us at least to have it in the language that, but there seems to be no progress, and the committee seems to rather go for adding reflection.
Yeah. Well, and I think that those mechanisms to try to have multiple ABIs that are coexisting usually run into the problem of what happens when you wrap a type from an older ABI in a type from a newer ABI and then wrap that differently. And there's some cases where it actually becomes really hard, and it could maybe be done in a way that technically will link and run. But my very strong belief is I think a lot of the implementers, especially on Clang and GCC, felt really burned by the partial ABI break for std string in the
Yeah,
plus 11 release.
that's true.
And a lot of that, I think, boils down to not, oh, this is the cost of ABI break. It's this is the cost of breaking ABI in a way that we can't diagnose. And so if you have reliable mechanisms that at link time you can be like, this is not going to work. I think the amount of like user support and anxiety would drop hugely. But even then, like 10, 15 years of accidental stability, like that's a third, half of the language's history. Yeah, don't change that. Like we should just admit that that's the way that it is and plan accordingly.
Yeah, and I think that the standard tries to expand in a lot of ways where actually the standard is not, C++ anymore. It tries to, like, we now have the CPS standardization tooling packages. That's all nice and good, but it's not C++ anymore. It's like a completely different world. And then I feel similar with ABI that this gets us into, and like also the linker, where we basically then often get into things where the committee likes to say, "Oh, that's implementation defined."
Yeah, and for a language of this age and complexity, and with this governance model, that's just what you're going to get. If we were in an environment where there's one implementation, whether there's a standard or just a reference implementation is a different question. And like people, it's a different governance model, and it's hard to. Our examples are languages that have this whole ecosystem governance, and it's hard to compare that versus C++, where we can specify only the language parts and not the implementation details.
That's true. I think related to that, you've done a keynote at CPPCon. I remember it still a little bit. Yep. So you argued back then to basically live at head.
Yep.
And how have your views changed on that, and how were the reactions to that? And basically,
I still think in theory that's correct. And the more that we can use that as the North Star, the better off we are. I think. So that talk happened actually before the Software Engineering at Google book. And in sitting down to write the book, the first step was really like, so what is software engineering and what are our major theses and themes? And we decided on how does this work over time? How does this work when you have, a different population of people involved? And really, what are you trading off? And so I, for years and years now, have said like, okay, if you're looking at a complicated thing and you haven't addressed how does this work with over time and how does this work with other people, you've solved the programming of it, maybe, but you haven't solved the software engineering of it. And the whole live at head philosophy or trunk-based development in DevOps terminology is so substantially about subtracting time from the equation. Like you don't have to be compatible over a substantial time window with every random thing that you might have done in the past. You really just need to integrate with yourself at one point in time. And the more that you can be in that sort of mindset and keep the compatibility time windows of yourself and all of your components as short as possible, like it's a lot of sort of small rote mechanical labor, but it reduces the conceptual complexity of it all is like so substantially that like that the value there is almost impossible to explain to people that haven't seen the difference. But
Yeah.
it starts bleeding into dependency management and questions about, you know, monorepo scaling and, you know, some of the hardest things in tech kind of are downstream from decisions like this. But at the same time, you know, all of DevOps research, DORA results, all of these things, like, yes, trunk-based development is a substantially more productive development model. So,
which brings us back to productivity.
Yes, like, and in the end, like, I lean on a lot of research like that because this is engineering. Like, this is a job. We're getting paid to do a good job, you know? If it was just, I want to do it this way because it's intuitive or appealing or fun, that's great for a hobby. Do whatever you want, you know? But if we're being paid, you should probably look at what is proven to be effective and what's not. But the hard part there is measuring productivity is basically impossible, at least on an individual basis. And it's a little bit like teaching. Like, one of the things that you get when you attend a lot of educational conferences is, I taught a class and it was great, because students didn't know a thing before and now they did, right? But we don't, and like that might be entirely true. What we don't have is evidence that that's a better way of teaching that material than other ways of teaching that material with the same class, like cohort and context. And I think, so it's really easy to say, like, my experience says that this works great. And we run into a lot of that when we have discussions about software engineering and workflow sorts of topics, because in my experience, there's no need for tests. In my experience, everyone is stupid. I don't know, like, I'm the only smart person in the room and I shouldn't have code review. Like, personal experience is not research evidence. And at the same time, the research is not always compelling and is hard to get right. And so it's a very complicated space to be operating in, I think.
And I think that's also for C++ a core problem that, you know, we move to new standards every 3 years, but for a code base to move to a new standard, you need tests.
Yeah.
And just like using a new version of a tool or anything, you need to be able to see, like, is everything still working? And I think we underestimate, and I've worked as a freelancer until 2012 before meaning C++ really started, and I have seen so many code bases, and I don't think that, like, a lot of companies have dedicated test departments.
Yeah.
But developers shouldn't waste their time with writing tests.
Yeah.
And that's really, really hard to do then to upgrade systems. And
it is. So there's a tech talk that I was doing at the beginning of the year. I think there's a couple recordings of it on YouTube, along the lines of design and testability are kind of highly interrelated. And one of the bits of terminology from the sort of architecture and design literature that I've really liked lately came to me from a friend, George Fairbanks. And he talks about control. And we can have intellectual control or statistical control or no control. And this is if you need to make a change to your system, like upgrading language versions, do you do this by understanding all of the behaviors of your system and the nature of the change in question, and being able to think it through real hard and prove to yourself that, okay, this is fine, just move on? Or do you have statistical control, which is some set of hopefully automated empirical mechanisms to get some evidence that this appears to be working? And like unit tests, test development or test departments, whatever it is. But you need like some control mechanism in there. And what we find is intellectual control is amazing when you've got it, and you should fight as hard as you can to keep that for as long as you can. But we all know that eventually the systems are going to be too complicated to understand at that level. And statistical control is a lot easier to get out of automated processes. So like, yes, please leave your future safety net in place. Like, give us a unit test. For the more complicated, bigger, messy tests, sure, offload that to a testing department or dedicated quality engineers or whatever, right? But like, I think we should be able to say pretty compellingly at this point that like, yes, it is the frontline engineer's job to write basic tests for the functionality that they're producing at the moment. Otherwise, we'll never have the control that we need to maintain this over time. It goes back to the, okay,
Yeah.
the difference between programming and software engineering.
And I've seen like one of the proposed productivity boosts for programmers is that AI generates tests.
Over my dead body.
Your take on that?
So I already mentioned Hiram's law. If we have the programmers write the code and then synthesize the tests, we have no way to know whether the behaviors that are now being tested were intentional or accidental, right? Because you can't infer properties like that from the static code, right? And so
True.
It's going to be just Hiram's law brittle test trap. It is a terrible idea. What the workflow that I do really like for this, that is like, oh yeah, generative AI would be great at this, is we need to go back to a little bit of design by contract. The lovely thing about AIs is they understand intent much better, and it doesn't have to be perfectly formal. And so you need a new component. Specify like basic contract at just like human level of, clarity. Have it synthesize, here are some tests and an API. Do these look like roughly the behavior and design that you were looking for? And iterate at that level until the usage looks correct and the API looks correct. And then let it synthesize the implementation. Like, I have no qualms about this. Like, I actually think that would work pretty well and be very sustainable. But yeah, the stuff of, well, let me just synthesize all of my tests is going to be like, well, I can write you tests that are not quite as good as that by just MD5, or like, let me take the cryptographic hash of your source code and fail the test if the hash changes. Like, you're just going to, wind up depending on every random behavior of your program, not the ones that mattered. And that will leave people with a worse understanding of tests and worse tests.
So are you involved with using AI in productivity at Adobe?
So the org that I'm part of is big on looking for new opportunities for AI in the developer workflow, adoption of GitHub Copilot and Copilot fine tuning, like custom models for your code base, things like that. Generally, I am totally in favor of these are good tools. They're just not going to solve everything. And one of the things that I say for any given new tech and hype cycle is like, as soon as someone can tell me convincingly what this isn't good for, I will start listening to them. And I think actually the best answer that I got for this so far was there was a piece in the New Yorker a couple of years ago, year and a half ago now, that ChatGPT is a blurry JPEG of the web. Just the idea of it is a lossy compression of the input corpus and with a funny query model. And if you start looking at it that way, okay, this is going to be, train it up on all of the C++ code out there.
Mhm.
Like, it will probably be pretty good at getting your code to compile. I have no reason to believe that it's going to be producing meaningfully better quality than the average of what it trained on the internet, which is not great. With fine tuning and local customization, you'd probably get some of that back. But I was not at all surprised to start seeing research results that are like the LLM, like generative AI assistants, are really valuable for junior engineers, mostly, I think, to get over the hurdle of like syntax and compilation.
Mhm.
And it's meaningfully better than autocomplete for senior people, because there are times when like, oh yeah, and now I just need to instantiate 10 of these for this set of types. And the AI will catch what you're doing there and start suggesting, expansions appropriately and take some of the rote out of it. So, I'd much rather have them than not. I just am worried that a lot of people are going to try to use it to solve problems that they're not good at. And then I'm also meaningfully worried about how does CS education work in the era of ChatGPT and Copilot? Because, yeah, like they can easily do the first couple years of an undergraduate degree. So now we're just relying on all of the 18-year-olds out there not to lean on automation to do their homework. But I do think that it's still important to like put in enough hours with the keyboard to become a fluent programmer and an algorithmic thinker. And you do just kind of have to beat your head against that to make that work. So it's going to be a weird few years.
I've seen Kevin Henney give a great example how he generated code for a talk about Kotlin at a Kotlin conference, and he doesn't know any Kotlin at all. And he got basically what he wanted out of the ChatGPT or something else he used.
Mm-hmm.
But the actual point he makes is not that he got a great code out of it, but that ChatGPT was very confident about the code and that all the code he showed you, and because it's Kevin, you believe that this is great code, is actually just a hallucination, and that all those nice sounding standard functions don't exist in Kotlin.
Oh, that's
And
unfortunate.
I think this is the biggest problem,
Yes.
and that actually hallucinations have not been solved and will probably not be solved, and that the whole AI is trained to do what you ask for.
Yeah.
And follow that path, and then seems to be the result you want.
Yeah. I do have a counterexample though. Like it's not all doom and gloom. I was doing some analysis of a spreadsheet that someone sent me, and they had there was like watch times on some videos or something, and they had watch times in one column as hour, minute, second. And I needed that to be something that I could take the average of or graph. And I was like, my Excel skill is not up to this task. Like, let me just go ask. It was probably Gemini. Let me go ask Gemini, like, how do you convert this in Excel? And it gave me two answers, both of which seemed like that's too good to believe. And then when I tested them, both of them were correct. It's like, that is incredible. Thank you for saving me an hour of dumb, like, not useful labor. Like, yeah, it was really nice. So it's, hallucination is a problem. Lack of practice is a problem. Making sure that we're generating the right things is a problem. Like, the criticality of being able to evaluate whether code is doing what you think it is definitely on the rise as a result of all of these things. And I don't know that we've coherently found ways to emphasize that skill.
That's true.
Yeah.
Actually, I saw weeks ago an article on. Did you see this article also? It was like pretty popular on the web.
No,
That basically does. This is a study actually, but I don't recall the full article, so I'm just wondering if you've seen it.
no, I have not. I will take a look for that.
But yeah, if you haven't seen it, then we don't have to talk about it now.
Yeah.
Anyways, I think it was very interesting to talk to you.
Always a pleasure.
I think it's such a great time to talk about, all the things you mentioned for your keynote: productivity, fear, and uncertainty, and how you should manage that in an organization and react to things and times.
Yeah.
So it's really valuable to see you in Berlin in 3 weeks for everyone.
Yeah. Thank you for having me here, and also for giving me both the opportunity and the forcing function to put all of those thoughts down on paper and share them with the audience soon.
Great. Then see you in Berlin, and
I'll see you soon.
thank you for the conversation.
Yeah. Thank you so much.